Welcome to lesson 4-10. It's the last lesson in the topic. We're going to be relating tables, graphs, and equations. How fun! All right, in this first problem, we have a booster club that are selling pom-poms to support their local charity. They want to raise $50 for this charity, and they buy pom-poms for 55 cents each. It looks like they're selling them for $1. We want to know how many pom-poms they need to sell to reach their goal. So first of all, we need to find out how much profit they make on each pom-pom. So if they sell it for $1 and they had to pay 55 cents for them, that's an expense, we end up making 45 cents per pom-pom. Now that we know the profit we make from one pom-pom, 45 cents, we're going to make a table to see what are some of the possible profits we could make. Now the number of pom-poms is my independent variable. Okay, so that's n, not x. And then over here we have r, which is the amount of money raised. If I sold 10 pom-poms, I picked an easy number, 10, because, well, I can multiply by 10 pretty super easily. 10 times 45 cents is $4.50. I just moved my decimal over one place. And towards the end of things, I think I'll pick 100 because that's easy also. That would give me $45. And maybe something in between, oh, I don't know, how about 50? That's in between. And in that case, I would profit $22.50 for our good cause. Now let's graph it. Here's a plot for each of my points. I plotted 10 for 50, 50, 22.50, and then 145. Let's write an equation to model this situation. I know that 45 hundredths, or 45 cents, times the number of pom-poms sold equals how much I raise. I also know that I want to raise $50, so I can put that in my equation. And then I can use my old friend algebra to find out the number of pom-poms I need to sell. So I could undo times 45 hundredths by dividing by 45 hundredths. That can be done as long as I do it to both sides of my equation. And what I'm going to get is n equals, let's do some side math, 50 divided by 45 hundredths. Uh-oh, the divisor has a decimal. I need to figure that out. I'll make it 10 100 times bigger as long as I do this, 10 100 times bigger. And then I continue on as normal. Now you may have already guessed I'm in a pattern here. It's going to keep going, right? So the one's going to keep repeating. But I can't sell 111.111111 pom-poms. So I'm going to actually have to bump that up. I'll have to reach my goal. I have to sell 112 pom-poms. Here's a new problem, very similar, except for now we're making 41 cents for each pom-pom we sell. I'll go ahead and fill in the table and graph and write and solve an equation to find out how many pom-poms they need to sell if they want to raise their $50. Go ahead and give it a try. Talk about it in class. Let's look at this next problem. We have the temperature. It was 6 degrees at 8 in the morning, and it increased 2 degrees Celsius each hour for 6 hours on a spring day. And we want to know the temperature after 6 hours. So we have this table, and we're going to relate hours, n, to temperature, t. So at the start, when n was 0, no time had elapsed, it was 6 degrees Celsius. After an hour, it was 8. After 2 hours, it was 10. After 3 hours, it's 12. And after 4 hours, it was 14 degrees. Well, as we look for a pattern, you might notice that we can't get from 0 to 6 except for by adding 6. You can't multiply 0 by anything to give you 6, so it's plus 6. But 1 plus 6 in the next row is 7, not 8. So it's not going to be a simple one-stepper. It's going to be a couple steps here. Maybe we can understand this better with a bar model. So on the top bar, we have 6 degrees. That's what we started with. And then we added a group of 2 every hour. And so this all together should be my temperature. So I have 6 degrees plus 2 times the number of hours that have passed. Let's see if that works. Well, for 0, I put 0 in for n, and 2 times 0 is 0 plus 6 is 6. That checks. 1 times n is 2 times 1 is 2 plus 6 is 8. That checks. 2 for n gives me 2 times 2 is 4 plus 6 is 10. It seems to work. 3 times 2 is 6 plus 6 is 12. 4 times 2 is 8 plus 6 is 14. So I found my equation. It does ask us to graph it, so let's do that right now. There are my 5 points that I have, and let's connect them with a line. There we go. Now I could read this line graph for any number of hours. Now it does ask me, and I could use the table to do this by continuing out, but it asked me for the temperature after 6 hours. Well, we could use our table. We could keep adding. At 5 it should be 16, and at 6 it should be 18. So there's using the table. Using the graph, I could find 6 down here and follow it up and then over, and lo and behold, it's 18. I could also use my equation here. 6 plus 2 times 6 is 6 plus 12, which is 18. So 3 different ways, same answer. Here's one for you to try. A company makes decorations for pens, and all the supplies are $5. And the company plans to sell the decorations for $2 a piece. I want a table, and then graph and write and solve an equation to find the number of decorations that must be sold for them to make a $15 profit. Go ahead and give it a shot, and we'll talk about it in class. How about some straight up practice here? We have a table. We have an equation, d, distance equals 5 plus 5 times the time, t. We're going to plug in some values for t, 0, and find out what d is, then 2, and find out what d is, and then you come up with your own, keeping in mind that our graph only goes up to 4. Then graph your 3 points, draw a line, and see if you can come up with a nice plot of what's going on. We'll talk about it in class.